Okay, what do we have here? Well, a buddy of mine asked me to look into why this kerosene heater doesn't work. Well, I'm convinced the answer is right there. Here's why. Well, not even why. I'm going to tell you what the solution is going to be. The boards are, I don't know, 150 bucks to get replaced. I'm pretty much convinced they failed. Here's the way a dumb thing works. Turn the power on. You set the temperature over on that board. It goes through 5 safety checks, and then it goes through a startup. And I'm not positive which one goes exactly first, but I'm pretty sure I know which one goes last. So the fan kicks on, which I think is first, and then I believe the igniter kicks on second, sparks in here, and then the fuel solenoid opens up and the pump runs, and that lets fuel in, and there you go. So what happened? The thing would keep shutting off and giving you code E1 on the display. So according to the book, if you have E1, you're supposed to look at dirty fuel filter. No, I pulled it out and checked it. No problem. The nozzle is dirty. I removed it, cleaned it, verified it was open, sprayed it out with carb spray, put it back on with Loctite. Photocell lens is dirty. No. In fact, my buddy had called the company and said he was having these problems. They sent him, I think for free because it was under warranty, 2 new photocells. It's not that. I checked the one on the machine and the ones that they sent with a meter, and they do show the change that they're supposed to show when you have light shining in there or not. I made sure it was lined up correctly. I also tried to run the machine and bypass the photocell by shining a flashlight directly in it, so I knew that it was registering that it sees the flame, and therefore that wouldn't be the cause of it shutting off. That didn't make it run. Still code E1. So photocell not installed properly or lens is dirty, neither one of those. Photocell is defective, no. All 3 bench test, fine. Improper electrical connection between the main circuit board and the photocell, no. I checked it. No corrosion, no nothing. So in the absence of those things, well, what else? Well, there's one of these ding-dings. I think it's a thermal protection thingy. Well, they sent him one of those too. That's been replaced on the machine. That's not the problem. What about insufficient pump pressure? So you're not getting enough flame and it just flames out? No. I checked it. I turned it all the way up till flames were shooting out the end of the machine, then cranked it back. I have 4 other kerosene heaters, so I know what it's supposed to look like when they run. That's not the problem. So the machine starts and runs, right? Well, until it says code E1. So I know the igniter works, or it wouldn't light. I know the fuel pump pressure is set correctly because I watched it. When it's hot, it's spewing forth the right amount of fuel. Well, it wouldn't be shooting fuel out if the pump didn't work. So obviously the pump works. Obviously the fuel solenoid over there works, or else it wouldn't run because it wouldn't open to let the fuel in. The fan runs just fine, it's strong. Well, there's nothing left. I took out the igniter, set the gap on the igniter. That's fine, checked out. So that's it. The only 2 sensors it has are that thermal overload and the photocell. That's it. Well, I know everything tests well. I know the machine runs. So the only thing left is that. And I think it's foolish to replace those with a $150 set of new boards when potentially the same problem could happen. Now, I do know this was squeezed into its housing right here. The plastic was physically bowed out because it does not fit in here. So they shoved this board that didn't fit in that plastic, or that shrank over time, but this thing's only 2 years old. I couldn't see any physical problems with these boards. I didn't see any physical bad solder joints. I mean, I didn't look at it with a microscope, but I didn't see any burnt components, anything like that. The display functions correctly. It gives you temperature. You can see the safety checks. and then you just get code E1. So somehow this is not getting the signal it needs to, telling it that the flame is lit and running correctly, and then it's not thermally overloaded with that temperature sensor thingy. That's it. There's no other sensors on the machine. So something on this board and all the wire connections to get to the board to tell it what those sensors are thinking, are seeing, is fine. So the only thing left is the board. Now what part of the board's bad, I don't know. I do not have the electronic skills to try to go through those and test components and see maybe the MOSFETs are bad. I don't know. So what am I going to do? Well, I'm going to do the right thing and eliminate all the safety features this thing ever had and make it all manual. And make 3 switches that you turn on one at a time and you turn off in the reverse order. So I'll make a switch that turns on the 120 volt AC fan, another switch that turns on the fuel pump, and opens a solenoid, which I think the problem there is, I think this transformer that looks like it puts out, can't read it. I think it says 10 volts AC. Anyways, my plan is unsolder that from the board, give it the 120 it needs, take the 12 volts out the other side, make sure that functions the solenoid correctly. Then that second switch I mentioned will run the pump and the solenoid. So it'll open the fuel and turn it on. Then the third switch will be the igniter. I think I said that in the wrong order now that I'm thinking out loud. The first one will be the fan, then you flip on the igniter, then you turn on the fuel. That's my plan. And then in reality, the safety checks on this thing says if it has problems at all, it kills the igniter and the fuel and leaves the fan running to blow any fumes, uncombusted fumes out and cool it down. So we're eliminating all the safety stuff, but there's nothing wrong mechanically with the machine that I could find. I've seen the injector nozzle. I know that this tube has no holes in it. The fan is good. The flame looks good in the chamber. There's nothing wrong physically with the functioning of the machine. The problem is that the sensors are tripping. So that's the plan. I think I will mount the switches someplace on the case itself. So you can put it all back together. You just flip 1, 2, and 3 switches and it fires up. And you shut it down in the reverse order of that. So let's see what happens. Well, let's see what happens. Don't worry, it's perfectly safe. That's off. Let's plug this little fella in here. Whoop. Now what do we got going? 110 to power strip, right? Goes to this cord, goes to the alligator clips, which gives the right side 120 volts. On the other side, going over to the leads of the probe here, meter set on 200 volts AC, and there's that. So when I flip this switch, A, I shouldn't see any smoke, and B, hopefully come over here and we find 10 volts AC. Let's see what happens. Oh boy. Easy. Whew. Whew. There you go. So, like I said, this is going to get wired onto one of the switches of 110 in that will then feed the fuel solenoid to open up so that it can get the fuel it needs to burn. All right, next step. Okay, just to show you, see I showed you. This is just on continuity. There's the thermal probe I wanted to see. I didn't know. Is it always open, always closed? So it's closed until and if it trips. The other one over there on the machine is the same way. So it's normally closed, and if it gets too hot, it breaks the connection. Whoa, who cares? Well, let's see what's going on. So I was trying to figure out how to do these switches I'm talking about, right? Well, the connections that go to that thermal overload probe, one comes from this yellow wire, comes from the motor, and I'm guessing it's wired in to one side of the AC. I need to take that cover off and find out. And I suspect then that it feeds AC, one half of it, over to the fuel pump, right? And the blue wire also goes up to that motor. So I think the yellow is one side of the AC connection, the blue is the other. The blue goes through that sensor, and I bet you that this blue connector then is normally 120 volt when the machine is on and running. And if that thermal protection kicks, it kills power to the fuel pump. And I'm not sure if it would to the motor also. But anyway, the point is, these wires go through that thermal overload sensor. One wire goes over to the fuel pump. The other one goes up here inside the motor housing. I'm going to take that screw off and see what the wiring is inside the motor case. Let's see what's in there. Oops, that's not the electrical input. Let's see if I can put this in here. Whoop, nope. Stuff's in the way, but anyhow, there you go. You can see it. It tells you right there. You don't have to open it up. It says yellow and orange are tied together. It checks out on the meter. It says blue and red are tied together. It checks out on the meter. That's it. And orange and red are AC power in. So there you have it. So 120 is supposed to come back out of the motor, these two wires right here, and one of them goes over to the pump, just like I said, and the blue one goes through the sensor first, the thermal sensor, and then goes over there to the motor. So that's how the pump motor gets 120 volts, is through the fan connection. But the sensor, I guess, controls running the pump. So let's proceed. Oh, that's nice. Didn't have the camera going. Anyways, what am I thinking? So the board acted as a switch to turn on the fuel pump, right? AC comes in, it went through the board. One of the relays in there sent power to the fan motor that also connected the yellow and blue wire to AC inside the motor unit. The blue wire of that AC goes through the thermal sensor and comes back to this plug. So this is ready for a switch to be installed. This would be another relay on the board that would basically flip a switch to send juice to the fuel pump. Send power to the fuel pump, assuming that the thermal probe is not tripped. It's normally closed, which means it's normally connected, and if it gets too hot, then it breaks that circuit. So whether the board broke the circuit or the sensor broke the circuit, one way or the other, you would be cutting power to the fuel pump. So we got that under control. Last thing is the igniter. That needs to get 110. I think from listening to this thing fire up before, I think the order of things was the fan kicked on, then the igniter, then the fuel. It may be that the fan kicked on, then the igniter, then the fuel pump, then the solenoid. I'm not really sure. I'm also not really sure that it matters. Seems to me that the fuel and the fuel solenoid opening would come on at the same time, because that way when it starts pumping, it has a place to go. It's not blocked by the solenoid cutting off the flow. So not sure, but there's going to be a panel. There is a panel that goes across this surface. I think that's where I'll mount the switches. I just got to figure out what switch is going to go to what item, and then we'll have to insulate that transformer in something, whether I wrap it all up in electrical tape. I haven't figured that out yet, but it'll have to get leads soldered onto it and stuffed in this area someplace. This will be used in a barn, so you know, it will have moisture in there. It's not like a pristine environment as far as moisture and dirt goes, so this needs to be well insulated. And you know what I mean, you can't have electrical components sitting on here in case any moisture ever got on the surface, so stuff needs to be raised up. Common sense. But I guess that's it. I don't think there's anything left except to wire in these switches and then test it out. So let me get things put back together and soldered up, the connections, and we'll see what happens. You know, the one thing I don't know, I guess I should research. I don't know if those thermal overload circuits reset or not, or if they're one and done. Because if they reset, which I think they do, as the temperature, if the temperature went back down, I think they'd come. Well, I better check, because then without a circuit board involved, if the thermal overload tripped, but it cooled back down, everything would come right back on. And let's say the fan failed, right? So it's no longer blowing air, but it keeps squirting fuel in there and the igniter's going. That's bad juju. That would mean all that heat would be stuck in the machine here, and we don't want that coming back on. If it trips off, then in this particular setup with the switches, the fan would keep running, but the fuel would shut off. Yeah, and now that I think about it, even if the fuel pump's not operating, that solenoid should shut at the same time. So I think this is making sense as to how I should tie the switches together, or at least the AC coming in together. I might only need 2 switches, one for fan and one for fuel and igniter. Nah, let me think about it. Just to make sure I'm not crazy, what I decided to do is test each individual system. So I got power coming in on the power strip. It's turned off at the moment, but the mains come in. All I got it tied to is the blower motor. Yellow and blue come out of the same connections, but they are disconnected. There's the yellow, it's isolated and insulated, and there's the blue. So nothing's gonna short out. Just wanna make sure. So this should obviously turn this way. I can't imagine it wouldn't, but let's test each individual part and see what happens. Go on, buddy, get out of here. I don't want to get your little nose in the fan, that'd be bad. All right, there's system number 1. All right. Let's move over to the fuel pump and make sure it works next. Okay, next test. Black wire, I tied a little jumper in that just goes to the switch, right? So the yellow wire, which I'm pretty much gonna consider the neutral wire on an AC. The yellow wire is still connected to the neutral side of AC going through the motor. Remember? The white in goes to orange, the orange goes to the motor. The orange wire in the motor connects to the white and the yellow, right? And that tests out on the meter. So what I'm saying is I sent the hot to the switch. The other side of the switch goes through that temperature sensor probe thingy there, comes back and goes over to the pump. So the pump has a yellow and a blue wire feeding it AC. Yellow is the neutral. The blue is the hot wire, if you want to call it that. I just turned the switch on because I don't want to fiddle with it when it's live with juice in it. So anyway, this should turn on only the fuel pump. The solenoid is off. Let's see if it does it. Yes. All right. So now we know that works. Now I'm going to turn the switch off and make sure it does not run now. Okay. The last thing we got to test is the igniter and the solenoid. That's next. All right. Next, I got AC going directly to the igniter. So let's test that out. I just ran the fan by itself for a while to clear out any fumes, so shouldn't ignite anything, but test it. I heard it. Did you hear it? All right. Can't see it, but I'm pretty sure that's fine. That's what it sounds like when it's running. So, all those systems are go. The last thing to test is the solenoid. I already know that's going to work because the transformer over here works. AC goes on this side of the coil, and I already soldered on the 10 volt AC side. So, I'm going to solder everything together, I guess, and we'll go test out the whole machine running. I think that's next. Okay, it's go time. Not that I don't have any faith in my work, but just saying. Keeping that handy. It's hooked up to power. Let's see if I can get you in a better spot here. In my way. Okay. Fire extinguisher ready. Hope for the best. Yeah. Come on, tripod. All right. Guess there's nothing for it. Let me verify. What do we got? All right, that's the igniter. That's the pump. Yeah, and what did I say? Igniter and solenoid. All right. Yes. Yes, that is correct. All right. Well, didn't hear anything blow up yet. Fan. Check. Fuel pump. Start a solenoid. Out the end, but it's hard to say. This might be getting up to temperature still, but have to give that a look. I'm going to turn it off. Turn off the igniter. Turn off the pump. Let the fan run. Well, that was surprising because I turned off the solenoid there at the end, or turned off the solenoid and the spark, but the pump was still on and it stayed running. I didn't think that should be able to do that, so I'm not sure why that solenoid didn't cut off, but I still think we're in good shape. It will clearly function like this. I'm going to let it run for, I think its built-in circuit board cool-down period was, I don't know, 2 or 3 minutes. Let's let it run for a while, but I think I'm going to get it fully assembled, and then I'm going to start it up again and fool with the pump pressure. Make sure it doesn't have too much pump pressure, it's not getting too much fuel. And then I think we're good to go. There it is. I did have some trouble starting it, so there's probably a better order of things, but I don't know what it is. I think it just got wet in there. I just don't know what order to, how I should divide those switches out. But anyways, once it did light, I did need to adjust the pump pressure, so that could have been it. It was just dumping way too much fuel in there and got the igniter wet. But anyway, there it is running. I got the pump set, it's just glowing red, but it's not shooting flames past the end. That's the way the book said it's supposed to work. So, I mean, I think I've been proven right that the problem was the electronics. There's nothing wrong with this machine. Obviously, the filter's not clogged. The igniter works. The fan works. The thermal overload circuit is still in there. I mean, I tested the photo cells. They tested good on the bench. The board should have been getting a signal that yes, I see ignition in the chamber. So the electronics were the problem with this machine, because obviously mechanically everything runs like it should. Well, I'm going to remove all those fancy schmancy junctions, temporary junctions, and solder those together and go from there. I don't think, I may experiment. I got to use my brain a little, which, you know, it's a struggle. But I need to see if it makes sense to tie the solenoid that opens the fuel to something else. I think I talked about that before, but anywho, I'm going to button this project up, resolder everything once I figure out the best way for it to go. I guess I'll need to try starting this thing up again and see how that works out. So we'll see. Okay, hopefully this is it. Wasn't happy with the last iteration. So now the first switch is wired to the fan. The second is the igniter only. And the third is the fuel solenoid and the fuel pump. We already ran it last time and got it to where we got the pump pressure set correctly. So hopefully this will be it. Before, I think it saturated everything with fuel and it wouldn't ignite, it got wet. But well, let's find out what happens. There's the pump, igniter, fuel. Perfect. All right, that makes me happy. Check out the end down there. Good. Shutdown, it should be exactly the opposite. Right? Fuel, igniter, leave the fan on, blow out any fumes and to cool it down. That's it. There's the finished product, ugly as it is, right? They're all soldered, dielectric gel inside the twist cap and then twist capped on top of the solder, so that's good enough, and the cheapest way I had to do it because I had twist caps laying around doing nothing. This, whoop, gonna go like that. There you have it. Okay, there's the finished product. There's some instructions. Oh yeah. Plug her in. See if we can electrocute ourselves one-handed. Oh yeah. All right, plugged in. Let's see here. And start. Fuel. What? Didn't ignite. What? Thanks for watching. See you next time.